Good day, everyone. I'm Ariel Cadirao, and this is my partner.
Richard Logronio.
Today, we're going to have our first regular webinar about solving inequalities using Desmos. But before anything else, let's have an opening prayer for us to enlighten our mind.
Lead me, Lord, lead me by the hand and help me face the rising sun. Comfort me through all the pain that life may bring. There's no other hope that I can lean upon. Lead me, Lord, lead me all my life. Walk by me across the lonely roads that I may face. Take my arms and let your hand show me the way. Show the way to live inside your heart all my days, all my life. You are my light, you're the lamp upon my feet. All the time, my Lord, I need you there. You are my light, I cannot live alone. Let me stay by your guiding love all through my life. Lead me, Lord. Lead me, Lord. Even though at times I'd rather go alone my way, help me take the right direction. Take your road. Lead me, Lord, and never leave my side. All my days, all my life. You are my light, you're the lamp upon my feet. All the time, my Lord, I need you there. You are my light, I cannot live alone. Let me stay by your guiding love all through my life. You are my light, you're the lamp upon my feet. All the time, my Lord, I need you there. I just cannot live alone. Let me stay by your guiding love all through my life, all through my days. So lead me, oh Lord.
let's graph ourselves some inequalities. So let's say I had the inequality y is less than or equal to 4x plus 3. And we want to, on our xy coordinate plane, we want to show all of the x and y points that satisfy this condition right here. So a good starting point might be to break up this less than or equal to, because we know how to graph y is equal to 4x plus 3. So this thing is the same thing as y could be less than 4x plus 3, or y could be equal to 4x plus 3. That's what less than or equal means. It could be less than or equal. And the reason why I did that on this first example problem is because we know how to graph that. So let's graph that. So if we, that's my, try to draw it a little bit neater than that. So that is, no, that's not good. So that is my vertical axis, my y-axis. This is my x-axis right there. That is the x-axis. And then we know the y-intercept. The y-intercept is 3. So the point 0, 3, 1, 2, 3 is on the line. And we know we have a slope of 4. We know we have a slope of 4, which means if we go 1 in the x direction, we're going to go up 4 in the y. So 1, 2, 3, 4. So it's going to be right here. And that's enough to draw a line, but we could even go back in the x direction. If we go 1 back in the x direction, we're going to go down 4. 1, 2, 3, 4. So that's also going to be a point on the line. So my best attempt at drawing this line is going to look something like something. This is the hardest part. It's going to look something like that. That is a line. It should be straight. I think you get the idea. That right there is the graph of y is equal to 4x plus 3. So let's think about what it means to be less than. So all of these points satisfy this inequality, but we have more. This is just these points over here. What about all of these that are where y is less than 4x plus 3? So let's think about what this means. Let's pick up some values for x. When x is equal to 0, what does this say? When x is equal to 0, then that means y is going to be less than 0 plus 3. Y is less than 3. When x is equal to negative 1, x is equal to negative 1, what is this telling us? 4 times negative 1 is negative 4, plus 3 is negative 1. Y would be less than negative 1. When x is equal to 1, what is this telling us? 4 times 1 is 4, plus 3 is 7. So y is going to be less than 7. So let's at least try to plot these. So when x is equal to, let's plot this one first. When x is equal to 0, y is less than 3. So when x is equal to 0, y is less than 3. So it's all of these points here that I'm shading in green. Satisfy that right there. If I were to look at this one over here, when x is negative 1, y is less than negative 1. So y has to be all of these points down here. When x is equal to 1, y is less than 7. When x is equal to 1, y is less than 7. So it's all of these points down here. And in general, you take any point. X. Let's say you take this point x right there. If you evaluate 4x plus 3, you're going to get the point on the line. That is that x times 4 plus 3. Now, the y's that satisfy it, it could be equal to that point on the line, or it could be less than. So it's going to go below the line. So if you were to do this for all the possible x's, you would not only get all the points on this line, which we've drawn, you would get all the points below the line. So now we have graphed this inequality. It's essentially this line, 4x plus 3, with all of the area below it shaded. Now, if this was just a less than, not less than or equal sign, we would not include the actual line. And the convention to do that is to actually make the line a dashed line. This is the situation if we were dealing, this would be the situation if we were doing with just less than 4x plus 3. Because in that situation, this wouldn't apply, and we would just have that. So the line itself wouldn't have satisfied it, just the area below it. Let's do one like that. So let's say we have y is greater than negative x over 2 minus 6. So a good way to start, the way I like to start these problems, is to just graph this equation right here. So let me just graph, just for fun, let me graph y is equal to, this is the same thing as negative 1/2 minus 6. So if we were to graph it, that is my vertical axis. That is my horizontal axis. And our y-intercept is negative 6. So 1, 2, 3, 4, 5, 6. So that's my y-intercept. And my slope is negative 1/2. Well, that should be an x there. Negative 1/2 x. Negative 1/2 x minus 6. So my slope is negative 1/2, which means when I go 2 to the right, I go down 1. So if I go 2 to the right, I'm going to go down 1. So 2 to the right, down 1. If I go 2 to the left, if I go negative 2, I'm going to go up 1. So negative 2, up 1. So my line is going to look like this. My line is going to look like that. That's my best attempt at drawing the line. So that's the line of y is equal to negative 1/2 x minus 6. Now, our inequality is not greater than or equal. It's just greater than negative x over 2 minus 6, or greater than negative 1/2 x minus 6. So using the same logic as before, for any x, so if you take any x, let's say that's a particular x we want to pick. If you evaluate negative x over 2 minus 6, you're going to get that point right there. You're going to get the point on the line. But the y's that satisfy this inequality are the y's greater than that. So it's going to be not that point. In fact, you would draw an open circle there, because you can't include the point of negative 1/2 x minus 6. But it's going to be all the y's greater than that. So it's going to be all the y's greater than that. And that'd be true for any x. You take this x, you evaluate negative 1/2 or negative x over 2 minus 6. You're going to get this point over here. But the y's that satisfy it are all the y's above that. All the y's above that. So all of the y's that satisfy this equation, or all of the coordinates that satisfy the equation, is this entire area above the line. And we're not going to include the line. So the convention is to make this line into a dashed line. And let me try my best to turn it into a dashed line. I'll just erase sections of the line, and hopefully it will look dashed to you. So I'm turning that solid line into a dashed line to show that it's just a boundary, but it's not included in the coordinates that satisfy our inequality. The coordinates that satisfy our inequality are all of this yellow stuff, that I'm shading above the line. Anyway, hopefully you found that helpful.
For this video, what I want to do is show you how to solve system of inequalities using Desmos. Desmos is a free online graphing calculator, and the thing that I love about it the most is I can take any equation, and no matter what form it's in, and enter it directly into the screen without having to solve for y. So what we have here is this a circle, and this is a line, and so what I'm going to do is graph both of these using Desmos and see where the region is that key overlap each other. Okay, and then I will do the second one. So I have this written down on a piece of paper. If you need to go ahead and write this down on a piece of paper and pause, and then get your Desmos so that you can try typing it in at the same time. Alright, so if I go into Desmos, I can either hit X and then use Shift and the number 6, which will give me the correct key, and type it in as x squared, or I can also use the keyboard down here. If you click on the keyboard at the bottom, then I could use the square button here. So there's a couple different ways that you could put this. And so our next equation is y minus 1, close your parentheses, and then we will also hit squared, and for this one it's less than 4. So as you notice, once I put the lesson 4, it does put it an dotted circle, so that you know that it is dotted. It also gives you important points. So if you're trying to plot this on your paper, you know what points it goes through. Okay, and then we're going to go ahead and put our line in here. So our line is x minus 2y, and I'm just using my keyboard to type this in and then I can hit the lesson or equal to negative 4. So all I did was enter the two equations that I had written down here, got so many things going on. And we can see that our overlap region is the region right here. So again, if you need it to, this gives you the points of where they intersect. So you can see how to graph, and it gives you important points so that you could graph this on your paper. So my answer solution would just be this region right here that's contained by the circle and the line, so I wouldn't shade everything. What I would do, and I wasn't going to do this, but I'll go ahead and write it down so that you can see how to do this on paper. So we would take from there, and we would see that our circle has a center at 0, 1, and then I would go out to in each direction. Okay, and then I would do a dotted circle because of the fact that it does not include it. And then for this one, like I said, you can get the points from here. Keep doing that. So if I click on the red line, it gives me a point. It goes through 0, 2 and negative 4, 0. So I'm just gonna plot those 2 points. So 0, 2, and what was it? Negative 4, 0. And this one would be a solid line because of the fact that it's included. So then our answer region would just be this part right here, that contained by the circle in above line. So it's the overlap of the two colors. So I wanted to at least show you how put it on onto paper. For the second one, I'm going to go ahead, just plug it in and see what the answer looks like in Desmos. Alright, so let's make sure I open the correct screen. Here, what you can do is you can just highlight on this and hit enter, or you could have also just hit the X button. I don't know what color will pop up next because it does change colors when I do that. So
In the continuation of our topic, I will give another example about linear inequalities with the use of Desmos. For this one, our first one is y is greater than negative x squared minus 3. So we can see that it's a parabola, and then our second equation is going to be x minus 2y is less than or equal to 8. Okay, so we really can't see because of this keyboard, so I'm gonna go ahead and minimize that, and we can see that our overlap would be everything that's on the outside of it. If I click on my red one, you can see that it would be everything that's above the parabola and also above the line, so it would be on the outside portion of here, and that would be my solution set. So with this, just a recap, I can use Desmos to help me quickly see with the graph would look like, so then I can put it on a paper. So like I said, this one is just a parabola that the vertex would be at negative 3. I would go over 1 down, 1 over 2 down, 4 to get my next point, and then on the other side, because it's symmetric, it does the same thing. This would be dotted because of the fact that it does not include it. It's just greater than. If I were graphing this one again, I can use Desmos to help me see if I click on the line what some of my points are. So we know it goes through 0, negative 4, and it also goes through 8, 0. Or we could look at some of these other points. Here we can see that at 2, it's at negative 3. That would be an easier point, so we could use 0, negative 4, and negative and 2, negative 3. So we would be here. Let me change color. This one would be solid, and the reason it ends up being greater than is right here because of the fact that my y is negative, and I'm circling on the wrong one, even though both of them, my eyes went directly to that one because they're the same. So because I'm dividing by a negative 2, if I were to solve this for y, I would have negative 2y less than or equal to negative x plus 8. And then when I divide everything by a negative, remember that if I flip, so it becomes y is greater than or equal to negative y plus 8, and then I can shade on the outside of both of them because it's greater than both of them. Okay, so it would be on the outside of this part and greater than the line. So everything up above. So with this, the purpose of this video was really to show you how to do it in Desmos. But if you don't know how to put it onto paper, then you're kind of a loss. So I went ahead and decided to give you then as well. Hopefully you enjoyed this video and learned. Thank you everyone for listening to us. And if you have any questions and suggestions, just drop it in the comment section below. And we will try our best to accommodate every one of you. And if you like our video, please don't forget to share, like, and subscribe to our channel, The Math Hunters. Again, thank you for spending your time with us, and we hope you enjoy our video. And God bless you all, and see you to our next webinar. Again, thank you.